Please welcome to the stage Chief Corporate Architect at Oracle, Edward Screven.
Thank you. Thank you. Good to see you all. So today I'm going to talk to you about three challenges that customers face and the way that MySQL Heatwave addresses them. So first of all, it's the data deluge. I mean, I think in 2020 or so, 1.7 megabytes per person per second of data collected around the world, right? The second is the need for cloud choice. Most enterprises, governments, commercial customers, they have multi-cloud strategies. They want to be able to take advantage of the best in each cloud, and frankly, they have applications in multiple clouds, and they need to be able to effectively use all of them. Finally, machine learning. We all see the impact that machine learning has in applications, the impact that machine learning has in the way we live our lives. But the truth is, machine learning is actually hard to use, right? Typically, it takes a lot of expertise, it takes a lot of experimentation. And if we actually want to use machine learning at the scale where it can be most beneficial, including in the kind of enterprise applications we build, we have to make machine learning available to everyone. Now, MySQL Heatwave solves and addresses all of those challenges. Now, if you don't know what MySQL Heatwave is, it's a single converged database that does both online transaction processing and analytics together in the same database. You don't need to use two different databases to process your transactions, store your application data, and a separate database to do analytics on that data. One single database does both. There's only one other database I know, one other cloud database that does both, and that's the Oracle database, the Oracle Autonomous Database running on Oracle Cloud. MySQL Heatwave does both transaction processing and analytics together in a single database, and it includes built-in machine learning. Now, customers who've been trying MySQL Heatwave, they love it. We have a lot of customers adopting MySQL Heatwave. We have a lot of customers moving from Amazon to Oracle Cloud Infrastructure just to use MySQL Heatwave. Then they do all kinds of interesting applications that are very different than the traditional MySQL application. Things like marketing analytics, gaming analytics, real-time monitoring of diabetes patients. Analysts also love MySQL Heatwave. I've worked for Oracle for 30 years, more than 30 years. I've never seen analysts comment on a product like the way they're commenting on MySQL Heatwave. IDC says, may very well be the single greatest innovation in open source cloud databases in the past 20 years. Wikibon says, the company's introducing material innovation after material innovation while other MySQL and cloud database vendors have failed to innovate in any significant way. Futurum says, MySQL Heatwave represents the fiscally responsible approach to cloud databases, while AWS Redshift and Snowflake represent fiscally reckless approach. ESG says, with MySQL Heatwave, machine learning is democratized. It's fast, uses up-to-date data, and costs less than other cloud database services. So I wish I could read all the quotes. They're all awesome, but we don't have time. There are a few simple reasons why customers are uptaking MySQL Heatwave, why analysts love MySQL Heatwave. The first is it's very fast. It's very fast. Every benchmark we run for MySQL Heatwave against the competition, Redshift, Snowflake, BigQuery, others, Heatwave dramatically outperforms them. 11 times faster than Redshift, 9 times faster than Snowflake, 9 times faster than BigQuery, 3 times faster than Microsoft Synapse. Now, the particular numbers that I was referring to were for a 4 terabyte TCPH benchmark. We run benchmarks of a wide variety of sizes. We see very similar results. Now, you may notice an asterisk up there where it says TCPH. The reason for that asterisk is we don't audit the results. We think there's a better way when it comes to MySQL Heatwave, and that is we take all of our code for the benchmark, all of our scripts for the benchmark, including what we do for MySQL Heatwave, what we do for Redshift and Snowflake. We put them on GitHub so everyone can see exactly what we did, everyone can download it, everyone can try it for themselves. And I encourage you all, try it for yourself. Try it on benchmark data, try it on your data, and you will see Heatwave just dramatically outperforms all the rest. Now you might also think, Well, okay, you got good benchmark results by throwing more resources at it in the cloud. You used a really expensive configuration of MySQL Heatwave to beat up Redshift and Snowflake. Absolutely not. Absolutely not. If we factor in the costs, it is even more better. It's even better. So basically, price performance on that benchmark, 23 times better than Redshift. Price performance, 35 times better than Snowflake. So MySQL Heatwave is both much faster and less expensive than the competition. Finally, I think the analysts are very excited by the unbelievable pace of innovation. So I'm going to invite Nipun Argal on the stage in a few minutes to give you a demo. He and his team have done a fantastic job of continuing to make MySQL Heatwave better. I mean, things like, since we launched, actually less than 2 years ago we launched, and in that time we've done things like we created MySQL Autopilot that uses machine learning and advanced optimization techniques to both improve performance and improve usability. We've added high availability, we've added replication channels, real-time elasticity, we integrated machine learning, and dozens of other things. And we haven't finished. So since April of 2022, we've done things like reduce the minimum cluster size, support up to 1.6 million tables. We've enriched the SQL language that can be processed for analytics. We've enhanced MySQL Autopilot so we can do better error recovery. So all of these things are innovation that help MySQL Heatwave customers as they use Heatwave, as it's in Oracle Cloud Infrastructure. We don't require our customers to upgrade the database. That's the beauty of cloud database. They just get to take advantage of these new features, as part of their application without having to do an upgrade. One other very important fact is that, of course, we continue to enhance and fix bugs, including security bugs, in MySQL that we deliver on premise, including open source MySQL. And so what that means is that because our cloud database, our MySQL Heatwave cloud database, tracks always the latest version of everything that we do in the on-premise version, every one of those enhancements, bug fixes, and security fixes get rolled into the MySQL database running as part of MySQL Heatwave without delay. That is not true of our competitors that are based on MySQL. Amazon Aurora is behind, right? I mean, so what that means is that when we fix a security bug in MySQL in the open source version, it takes a few releases before Amazon catches up and fixes the same security bug. Now, how does MySQL Heatwave actually address these problems? How does it address the data deluge problem? And it really is a deluge. I mean, since 2020, in 2020, what was it, 79 zettabytes of data collected? Almost none of it actually used for anything useful because it's too hard, right? Almost all that data is stored in files. Now, you can take that data and you can load it into databases to process, and a lot of times people do, and that's useful. But it's also a barrier, right? I mean, it's managing that load process, having to have separate storage for the data. It's expensive, right? It's time consuming. Well, today we're announcing MySQL Heatwave Lakehouse. What that means is that MySQL Heatwave can directly query data in files in Object Store. So you do not need to load the data into the data storage of MySQL in the cloud. MySQL Heatwave directly loads the data from the files and processes it using analytic queries. Now, I mean, this is astounding, right? That means you don't need to go through an ETL phase in order to use the data that you have. And you see right on the bottom left of the slide, if you can make it out, it's very straightforward. There's a little bit of DDL that maps the files in Object Store into the MySQL metadata, and then you run a query, and that's it. That's all you do. Is it fast? It is very fast. We wanted to challenge the MySQL Heatwave implementation for Lakehouse, so we ran a 400 terabyte TCP/H benchmark. 400 terabytes. That's 512 Heatwave nodes. The average query response time, 42 seconds. Now, I don't know if you know anything about TCP/H, that is very fast, and 400 terabytes is very large. In fact, if you use the TCPH tool, you know, the transaction processing council that produces these benchmarks, they give you tools to actually generate the data. If you try to actually generate 400 terabytes of data using their tool, they give you a warning. It's actually only defined up to 100 terabytes. We also ran the same benchmark against Snowflake and Redshift. So again, 400 terabyte TCPH benchmark against Snowflake and Redshift. So MySQL Heatwave Lakehouse, 17 times faster than Snowflake, 6 times faster than Redshift. You might also be wondering, hey, you know, did I throw extra hardware at it, you know, somehow with Heatwave in order to make the results look better than they really are? The answer is no. Our configuration is about 30% cheaper than the configuration we use for Redshift. Is about 30% cheaper than the configuration that we use for Snowflake. Another factor for when you're going to process data directly from the files is, well, how fast can you read the data out of the files? Right? Because, you know, we can run the queries really, really fast. But if we can't load the data quickly, well then, you know, that's going to become the bottleneck. So we compared the load time of Lakehouse against Snowflake and Redshift. We load the data from the files 2.7 times faster than Snowflake. We load the data from the files 8 times faster than Redshift. Now this is very interesting. And just kind of taking a step back and thinking about this. Snowflake's entire business is based on loading data and querying data from files. That's what they do. I mean, that's their entire business. We added Lakehouse support to MySQL Heatwave, and we beat them in every way that matters. We query 17 times faster, we load 2.7 times faster, we have 30% lower cost. Another good question is, well, all right, how does it compare, how does querying data in files compared to querying data that's already in the optimized format stored in the MySQL database service? Well, of course, we ran the same kind of comparison. And so here we have two benchmarks, a 10 terabyte benchmark, a 30 terabyte benchmark. The query time is the same. It's exactly the same. So you get the same great performance whether you choose to store the data in MySQL, in a native MySQL database format, or you choose to keep the data in your files. Now, one of the key technologies that's helped us achieve such amazing performance, both with analyzing data that's stored in MySQL database files or analyzing data that's stored in object store files, is MySQL Autopilot. As I mentioned, it uses machine learning and advanced optimization techniques to figure out how to run queries better, figure out how to load data better, figure out how to place data better, figure out how to compress data better. And so when it comes to Lakehouse, Autopilot can look at your files and it can figure out the right schema to use. It has optimization techniques that pull data out of object store as fast as it will go. It uses adaptive sampling techniques because you have massive amounts of data. You need to collect statistics on the data, but you have to do it in a way which is clever, right? Otherwise, collecting the statistics will actually become the bottleneck. It automatically watches the queries you're running to collect statistics of query execution in order to figure out how to run the query better next time. We can query directly out of object store multiple file types, CSV files, also Parquet files. Because we can do Parquet files, it means that we can actually also directly query Aurora and Redshift exports. And to give you a demonstration, I'd now like to call on stage Nipin Agarwal, who's Senior Vice President of MySQL Development.
Thank you, everyone. What I'm going to show you today is how you can use MySQL Heatwave to process hundreds of terabytes of data which is stored in the object file very efficiently. And for this, I'm going to use a 250 terabyte data set, and it takes 2 hours to load this data. So that's why what I'm going to show you is a recording of the steps. To start off with, we go to the OCI dashboard and we pick an instance of the MySQL database, Heatwave, which has been provisioned for Lakehouse. So when we pick an instance of MySQL Heatwave, if Lakehouse is provisioned, that's a cue that this instance of MySQL Heatwave can process data from the object store. For this demo, we're going to use 250 terabytes of TPCH data. TPCH has 8 objects, And these files are loaded in the object store in a variety of formats. So we have files in CSV format, in Parquet format, files which have been exported directly from the Aurora database, and a couple of objects are also loaded in the MySQL database. So what we have is an aggregate of 250 terabytes, and the largest file is the line item table over here, which we're going to start with. So we can load all of these files in one shot into MySQL Heatwave to start processing, but for this illustration purposes, I'm going to walk through one file at a time. The largest file is line item. It's about 200 terabytes in size, and we're going to use Autopilot to load this file. So the only thing I need to do is to invoke Autopilot, and what Autopilot does is it intelligently samples the file, runs machine learning models, and comes up with some interesting predictions. So here, Autopilot is predicting that the size of the file is 195 terabytes, it has 16 columns, and it's about 1.5 trillion rows. Autopilot can also make predictions about the runtime characteristics. So it's predicting that on an average, there are about 16 columns over here. It's going to take 98 terabytes of memory, both to load the data compressed as well as the intermediate memory required. It's predicting it's going to take 2 hours to load this 200 terabytes. It's going to require 211 nodes of Heatwave. And all the SQL commands that are required to load this file into Heatwave are automatically generated by Autopilot and written to a script. We're now going to use the script to see what it contains, and for this, I'm going to invoke VS Code for MySQL shell, which has been enhanced for MySQL Heatwave. So when we look at this file, we see that for all the 16 columns, Autopilot has defined what is the appropriate data type mapping to the database. For each of the columns, what's the appropriate precision for the number columns, what's the appropriate max width size for varchars, and if any of these columns have nulls or not. So all of this information has been automatically populated by Autopilot. Now the only thing which we need to do is to run the standard MySQL command to load this into Heatwave. And this is something which we can do by the standard alter table command. So I'm going to execute this command. And when we execute this command, what is happening is that all of this data is being read from the object store in parallel into Heatwave. So one of the interesting things we have now done with Heatwave is that we are able to load the data in parallel in addition to processing the queries in parallel. So I issue the alter table command, and we see that we are able to load 200 terabytes in 2 hours, and the file indeed does contain 1.5 trillion rows. So very much in line with the prediction Autopilot made. The same capability is available by Autopilot for other files. So similarly, we can take files which have been exported from Aurora, files which have been exported from the Redshift database, and load them directly into Heatwave. Same process, and we execute the alter table command to load this file into Heatwave. So in total, there are 8 objects with TPCH. What I'm going to walk you through are 3 of them. The remaining 5 we have loaded in the background. So after I load the Aurora export file, the last table I'm going to show loading is from the MySQL database. Now at the end of this, what I have is a 250 terabyte data set, which has been loaded into a Heatwave cluster of 300 nodes. And this was done, as you can see, by Autopilot without any human intervention. So now the system is ready for running queries. What I'm showing over here is a fairly complicated query. It's an 8-way join across 7 tables. We're going to execute this query, an 8-way join query, on 250 terabytes of data, and let's see how long it takes. And you can see this is all using standard SQL syntax, right? So there's no proprietary extension. Users can use the standard SQL syntax for querying files in the object store. There you go. So we were able to execute this query, 8-way join, on 250 terabytes in 41 seconds. Now, MySQL Heatwave provides support for real-time analytics. So any changes which are made to tables in the MySQL database are propagated in real time to Heatwave. So what I'm going to do is I'm going to now go ahead and update a table in the MySQL database. I'm going to rerun the same query which I had shown you, and hopefully the results are going to be updated. So I'm rerunning the same query with the table updated. Yes, and as you see, the column has been updated. So what I've just shown you is by using MySQL Heatwave, we can now process hundreds of terabytes of data stored in the object store in a variety of file formats very efficiently, both for loading as well as for query processing. Thank you.
All right, thank you, Nipun. Now we'll hear from Nipun one more time, a little bit later for another demo. All right. So now let's talk about cloud choice. As I mentioned, most enterprises actually have a multi-cloud strategy. They know that they need to be able to use the best of each cloud. They know that they have applications and data in both clouds. Sometimes there are geographic distribution reasons why they choose one cloud or another. In the case of Oracle, maybe they use Amazon for public cloud, and they use Oracle for dedicated regions within their own data centers. There's lots of reasons why it makes sense for customers to use more than one cloud. So now when we talk to a lot of customers about using MySQL Heatwave, many of them told us, well, sounds good, but I've got my application in AWS, and Amazon charges too much money for data egress for me to use MySQL Heatwave running in Oracle Cloud. The latency is too high because the network is not that great, right? And if I move my whole application, there's unfortunately some proprietary AWS services that I depend on. It would make it hard for me to actually move the application. So what we've done is we've made MySQL Heatwave available in AWS. So today it's available production in AWS. Now when I say it runs in AWS, it completely runs in AWS. The console, the control plane, the data plane, all are running on AWS infrastructure, all within AWS's network. If you build an application that runs in AWS and it talks to MySQL Heatwave running in AWS, there is no data egress. The latency you get is the latency of the AWS network. It's the same functionality as what we offer in Oracle Cloud Infrastructure. It's the same code that we use in Oracle Cloud Infrastructure, modified to be optimized for AWS infrastructure. It's fully managed. It's, again, one single database, both online transaction processing and analytics. You get built-in machine learning. And of course, it uses MySQL Autopilot. In fact, we've changed MySQL Autopilot in a couple ways to be able to do a better job in AWS. You get an integrated console. It's easy to use. One single environment for monitoring and managing every aspect of Heatwave, including machine learning, autopilot, just querying the data, looking at the data. Now you might wonder, well, okay, how fast is it? I mean, we built Heatwave to run in Oracle Cloud Infrastructure. We really tuned it, to take advantage of every single thing we could in Oracle Cloud Infrastructure. So it must be slower when you run inside AWS. In fact, because Redshift was built in AWS by Amazon, surely, they get performance advantage because they have home field advantage. Well, the answer is no. We worked very hard to optimize MySQL Heatwave in AWS, just like we did in Oracle Cloud Infrastructure. And as a result, when we run TCP/H benchmarks comparing Redshift and MySQL Heatwave in AWS, we are 20 times faster than Redshift in AWS. Heatwave in AWS is 16 times faster than Snowflake. Now, Snowflake is not built by Amazon, but most of Snowflake runs in Amazon. How about the cost? Okay, everyone understands, at least I hope everyone understands, that Oracle Cloud Infrastructure is much less expensive than AWS infrastructure. And when we run Heatwave in Amazon, when we run it in AWS, we have to pay AWS for that infrastructure, right? And we don't get a good deal. Okay, so surely we must be more expensive. We must be more expensive than them in AWS. The answer is no. We still have better price performance, much better price performance than Redshift and Snowflake and BigQuery and Synapse when we run in AWS. If you run MySQL Heatwave in AWS, so it can talk to your applications that are running in AWS or consume data that's actually stored in AWS, you get 7 times better price performance than Redshift, 10 times better price performance than Snowflake, and on and on. Now, I mentioned that we modified MySQL Autopilot in order to take advantage and deal with the fact that we're running in now multiple clouds. One of the things that happens when you run in more than one cloud is you have to deal with the fact that, okay, now you have different kinds of, a wider variety of processors, a wider variety of physical servers, a wider variety of networking, memory, memory, et cetera. The shapes are just different. So in order to do that, right, in order to make it tractable for our users, we added auto shape prediction to autopilot. So what it means is that if you have a MySQL instance, a MySQL Heatwave instance, and you're not sure if you've sized it correctly, you can use auto shape prediction built into MySQL Heatwave to tell you, okay, what size shape should I use given my actual workload, right? Sometimes it will tell you, hey, it should be bigger because you don't have enough of the data in memory, so performance is too low. Sometimes it will tell you, hey, your shape is too big, you're wasting memory. You should use something that's smaller, which costs less. And actually, that is probably the more common case, just because I think most customers, when they choose shapes for something like MySQL Heatwave, they tend to over-provision because they don't want to run slow. Well, if you use auto shape prediction, we'll tell you, spend less money, use a smaller shape. Another thing we had to deal with was the fact that the variety of just the wider variety of hardware that we're dealing with means that we have to do a better job with thread scheduling. Okay, so we implemented something we called auto thread pooling, which lets us actually do a much better job of reducing contention no matter what kind of shapes we're running on. And this had a great side effect. It meant that when we're not memory bound, when the data of the application fits in the buffer cache, which generally is what you want, we are much more scalable than Aurora. In fact, 10 times more scalable than Aurora. I'd like to invite Nipun back on the stage for one more demo.
Thank you, Edward. So what I'm now going to show you is how to provision a MySQL Heatwave instance in AWS, what is the latency of accessing this service within AWS, and how can you efficiently move data which is stored in Aurora or RDS instance to MySQL Heatwave. So to start off with, users need to go to cloud.mysql.com. So I'm going to start with cloud.mysql.com. I'll enter my credentials, and I come to this landing page, and from here, I can provision the instance, I can run queries, I can monitor the performance of the system, I can run machine learning, right? So all these capabilities are possible directly from the console. To start off with, we're going to create a MySQL Heatwave instance. So I'm going to enter the various information necessary to create a MySQL database. Like we're going to go with the latest version of MySQL. Now, one of the things I'm going to specify over here is the availability zone. So I have the opportunity to specify which availability zone. So we're going to pick US East AZ1. And then we will enter the information required to create the Heatwave cluster. So we're going to go with the larger shape of Heatwave, and we're going to provision a 4-node Heatwave cluster. Once this is done, the Heatwave instance is created inside AWS. So when we look at the information and the details, we see that the Heatwave cluster was created, the MySQL instance was created in AZ1. So MySQL Heatwave is running inside AWS. Now, one of the things we'd like to do is to see that what is the latency of accessing this MySQL Heatwave instance which we just created. So for this, I've created a compute instance in the same AZ, and we're going to check the latency for accessing the MySQL database. We see that it takes 0.4 milliseconds. So what this means is that for many of the database applications which are very latency sensitive, this is a very good solution. The next thing we're going to do is, I have an instance of RDS in the same AZ where we have a bunch of data, and we're going to use the data migration service to move data from RDS MySQL to MySQL Heatwave, which we just created. Right? So the data is going to be replicated from the RDS instance to Heatwave using DMS service. Now, the first thing we observe is that the DMS also is created in the same AZ, AZ1. So the RDS instance, the DMS, and MySQL Heatwave, they are all in the same AZ. So there is no data egress which is happening to the internet. We start the replication. The data is now being moved from RDS into the MySQL database, and all the tables which are in RDS will start getting populated to the MySQL database. Once the tables appear on the MySQL side, using the same autopilot, we can load the tables from the MySQL database into the Heatwave memory. So now I have the tables on the MySQL side, and I'm going to use Autopilot to load them into Heatwave. And now the system is ready to query MySQL Heatwave. So what we just did is that we replicated data from RDS to MySQL Heatwave, so customers can now get all the benefits of MySQL Heatwave, which is better performance and a lot of these capabilities. And all of this was happening while the data remained inside AZ1, inside the same availability zone, so there was no egress to the internet. So what I've just shown you is as to how easy it is to create a MySQL Heatwave instance in AWS. The latency of accessing this is very low, and there is no data egress to the internet. Thank you. Thank you, everybody.
All right, thank you, Nipun. Now, I mentioned a few times about the importance of the fact that MySQL Heatwave is a converged database. It handles both transaction processing and analytics together in the same application. Now, one benefit obviously is like, okay, I don't need to move my data out of my transaction database into my analytics database. I don't need to manage that integration. I don't have additional security risk because, hey, maybe the data is sitting in an object store for a while. So it's all together, it's secure in one single place. That's obviously a tremendous advantage. Another advantage, which is a little more subtle, is that really there's no such thing as a pure transaction processing application. I mean, very, very few times do you actually come up with a real application where you don't run complicated queries sometimes directly on that transactional data, right? And so one thing that we found is that one of the things that the customers in Amazon who've used our limited availability version of MySQL Heatwave, because we've made it available to some customers so they can try it. One thing that we found is that what they really love is the fact that their complex queries in their transactional applications now run very fast. So Johnny Bytes found 60 to 90 times faster execution of their complex queries compared to AWS, RDS, and Aurora. 6D Technologies, 139 times faster complex queries compared to AWS, RDS. Bio9, 50 times faster complex queries compared to AWS, RDS. Centroid, they've improved their query performance by 15 times without changing their application. And I think this is true for pretty much anyone who builds transaction processing applications against a MySQL cloud database that isn't MySQL Heatwave. Now, I've talked a lot about multi-cloud. So far, I've only talked about two clouds, okay, which is Oracle and Amazon. Now, I guess that's multi-cloud. Seems like three, though. Three is when you get to multiple, right? So today what we're announcing is MySQL Heatwave on Azure. Not only can you use MySQL Heatwave in Oracle Cloud and in Amazon, you can also use MySQL Heatwave on Azure. Now, the way we do it on Azure is different than Amazon. Because Oracle and Microsoft together both believe in multi-cloud, we've worked to actually create high-speed interconnect between our data centers. It turns out many of our data centers are actually located very close to each other. So we get high performance, low latency network connections between their cloud network and our cloud network. And so right now, MySQL Heatwave on Azure is limited availability. So if you have an application in Azure, you can use MySQL Heatwave without paying egress fees, without paying a latency penalty. With MySQL Heatwave, you get the choice of where to run. You could run in Oracle Cloud Infrastructure, you could run in AWS, you could run in Azure, and actually you can run in your own data center. If you get an Oracle dedicated region in your own data center, of course you run MySQL Heatwave. Now let's talk about the last concern, the last thing that I mentioned in the beginning, which is machine learning for everyone. All right? I mean, we all understand exactly how important and compelling machine learning is. I mean, and it's not just things like translating, from one language to another, doing image recognition. It's not just that, right? It's how do we actually improve the experience of users in enterprise applications. We've done a lot of that inside Oracle. Our SaaS applications use machine learning broadly, right, to help do things like, prioritize resumes to review, handle expense report submission, and much other kinds of mundane things related to like task routing, Well, how is it that we're able to do all that machine learning work? Because if you have done machine learning yourself, or you try to do machine learning yourself, then you know that it's actually not easy. I mean, first thing you have to do, you have to get a bunch of data, you have to clean that data, you have to manage that data, and whenever you're doing that, I mean, you're talking about moving data around between objects, different kinds of object storage or files, okay, you create potential security issues, right? You create exposures of sensitive data to lots of different employees, right? I mean, how do you deal with that, right? Then once you've got the data, you've got to decide, all right, which particular machine learning algorithm am I going to use? Am I going to use boosted trees? Am I going to use logistic regression? Am I going to try some sort of deep neural network model? Many other kinds of algorithms too. Once you pick one of these algorithms, okay, all of these algorithms have lots of what are called hyperparameters, like knobs that you have to tune correctly for the algorithm to actually have a good result. It's very easy to have ineffective machine learning, right? Using traditional approaches and techniques, it's hard to have a good effect, right? Now, once you do all that, let's say that you manage to pick the right algorithm, you manage to pick the right features in the data to train the algorithm with, you manage to pick the right hyperparameters, you now have to run an expensive training procedure, right? Training can take a long time. It can be very expensive, right? If you're running on compute infrastructure, you're basically spending a lot of dollars in order to actually run that training process. And finally, when you're all done, let's say you're successful, you managed to get through all of that, all right? You now have a model which, using traditional tools, is a black box. It means I can't understand why the model makes certain decisions. I can't understand, there's no explanation about why did the model, consume certain features in certain ways. There's no explanation. It's a black box. Heatwave AutoML is very different. We use the AutoML technologies that we built in Oracle Labs to enable our practitioners inside Oracle to use machine learning widely. We put it into MySQL Heatwave. We automatically choose algorithms. We analyze the data, and based on what we analyze, we can figure out what is the best algorithm to use. What are the best features to use? We manage the training process. Of course, all the data is together in one place, which means that it's secure. Right? Once we finish creating a model, we have explainability. We can tell you why. Why did the model use certain features? For a given inference, like when you actually use the model to basically do a classification or do a regression, we can tell you, all right, what were the factors that caused this decision? Hire, don't hire. Prioritize this lead, over others. We can tell you why the model made that choice. We don't do just only simple kinds of things. I mean, regression and classification, that's probably the bulk of what you do in enterprise applications when it comes to machine learning. But you also do more sophisticated things, like, for example, time series-based forecasting. That's a new capability that we've added to the machine learning that's built into Heatwave. We could automatically generate a forecast model. Now, I talked about explainability just a bit ago. And it's incredibly important. It's incredibly important to make machine learning be explainable. For one thing, there's a lot of regulation you got to comply with. If you're making decisions about people, there are a lot of fairness laws and fairness regulations, that you may be challenged on based on your machine learning approach. We all want to be fair, but if you can't explain why your machine learning model made a decision about a person, how do you know it was fair? How do you know that the model didn't bake in biases that you want to eliminate? You need to be able to have people trust your model. I can tell you one difficulty that I've seen happen when customers try to use machine learning models is that while the data scientists are really excited and sure it works, other people in the company are not. Now you can run experiments, you can show them that yes, in fact, results are better when you use a machine learning model, but still, if you can explain the model, if you can open up that black box thumb, okay, you get a lot more trust in the organization, and you get a lot more agreement to actually use the model in practice. training speed is very important. The data that you use in order to actually train your models is not stationary. The distributions of the values of the features in the model, they change over time. So what that means is you have to rerun training. Now, if training is slow, and many training techniques, traditional training techniques, are very slow, well, that means you can't afford to train that often, which means that your model underperforms. So we've worked very hard to make the training that we have inside MySQL Heatwave be very fast. When we compare it to Redshift, Redshift says they have machine learning built in. When you compare it to Redshift training, we are 25 times faster than Redshift. Okay? Redshift training, by the way, is not free. I mean, of course, you pay for all the compute that gets consumed during the training. We're 1% the cost of Redshift training. Okay, let's look at how Redshift training works versus Heatwave. Okay, so Redshift ML, it's not really built in. When you do training, when you do training, you have to actually use another kind of technology called SageMaker, right? To actually do the training, you have to pay for SageMaker. Okay, when you do a training run, you have to give it a time budget. You have to say, don't consume more than this amount of time, right? Because if you do, if you exceed that number, that amount of time, okay, the training terminates, right? So you just wasted your money. So you get to try it again. Okay, so what really happens in the real world is you get multiple iterations of these training cycles trying to actually get the thing to train. You don't do that with MySQL Heatwave. We manage the entire process. There's no time budget. We run 25 times faster anyway. It's actually effective and built into MySQL Heatwave. If you want to get any kind of explainability out of Redshift, you have to actually get the explanation as part of the training process. So they'll give you some explanation about the model. They do not provide explanation of inference. They don't tell you, they can't tell you on an individual use of the model why the model made a decision. With MySQL Heatwave, you can generate an explanation for the model at any time after you've created the model. And also, we give you explanations of individual decisions made by MySQL Heatwave ML. Now, I've talked a lot about how we automate that machine learning process. We do also allow you to influence that process. So if you have data scientists who actually do have the expertise and they want to influence the pipeline, it's no problem. You can subset the algorithms that we'll choose from. You can subset the features that it will choose from. You can specify optimization metrics. And in fact, if you have some completely different machine learning pipeline, we've generated the model separately from MySQL Heatwave, you can just inject that model. So there's a standard called Onyx that is used to represent models. We can take an Onyx model directly into MySQL Heatwave, and then you can use it at runtime within Heatwave. So putting that all together, we have democratized ML with MySQL Heatwave. All those machine learning features, they're available in MySQL Heatwave without additional charge. I mean, you don't pay for some separate set of machine learning features. It automates the entire life cycle. It's incredibly fast, and in my mind, very importantly, it is explainable. I mean, if you use MySQL Heatwave for machine learning applications, you can let your broader developer set actually effectively apply it to your applications. So we've talked about now 3 challenges. We've talked about the ways that MySQL Heatwave addresses those challenges. Now, there's a lot of other things I wish I could tell you, but we actually don't have time. I wish I could tell you about our VS Code plugin. Fantastic tool. If you're a developer and you want to use MySQL Heatwave, definitely use the VS Code plugin. I wish I could tell you about the hypergraph optimizer we've just implemented that greatly speeds up query execution in the analytics engine. I wish I could tell you about the machine learning enhancements we've made to autopilot, which also doubles the query performance and for many benchmarks. Fortunately, though, there are other sessions at OpenWorld, right, that talk about, CloudWorld, that talk about MySQL Heatwave, okay? So there's a MySQL Heatwave Lakehouse presentation tomorrow at 5. There's a MySQL Heatwave on AWS presentation today, actually, at 5:15. And there's a MySQL machine learning presentation tomorrow at 2:30. So thank you all very much.